Good day everyone. Today I will be discussing an important topic in trigonometry, the graphing of trigonometric function. We will explore their periodicity and amplitude, analyze their general behavior and determine their domain, range, and k characteristic. Additionally, we will examine how changes in period and amplitude affect the graphs of these functions. To begin, let us recall the 6 fundamental trigonometric functions. So we have sine, cosine, tangent, and their reciprocal. We have the cosecant, the reciprocal of sine, and we have secant, the reciprocal of cosine, and we have cotangent, the reciprocal of tangent. So this is the 6 trigonometric function. To begin with, let's talk about the general form of the cosine and sine function. So for sine, we have y is equal to a sin b x plus c plus d. A stands for amplitude, b stands for the period, c stands for phase shift left, d for vertical shift. And for cosine, we have y is equal to a cos bx plus c plus d. So the sine and the cosine function have a similar general form. Now let's try to solve the basic sine graph. So as we observe in the unit circle, the y value starts from 0. We have here amplitude of positive 1 and negative 1. So we have a pi over 2 or the 90 degrees, we have pi or the 180, and 3 pi over 2 or the 270 degrees, and a period of 2 pi. And now let's try to graph. As we observe in the unit circle, the y value starts from 0. So we have a 0, and then 90 degrees or the pi over 2, we have positive 1, and then pi we have 0, in 3 pi over 2 we have negative 1, and in 2 pi we have 0. So we start from 0, goes up to the maximum, back to the midline, goes down to the minimum, back to the midline. So this is the basic sine function. The y is equal to sine of x. Now let's move forward to the cosine. So the basic graph for cosine is y equals cos of x. As we can observe in the unit circle, the x value starts from 1. So we have here the pi over 2, the pi, the 3 pi over 2, and the period of 2 pi. That the x value starts from positive 1, and 90 degrees, the x-axis is 0, and pi, the value of x is negative 1, and in 3 pi over 2, the value of x is 0, and in 2 pi it is 1. So let's start from the maximum, goes down to the midline, goes down to the minimum, goes up to the midline, back to the maximum. So there are few similarities between the sine and cosine graphs. They are both have the same curve which is shifted along the x-axis. Both have the amplitude of 1, have a period of 360 degrees or a pi or a 2 pi radians. So now let's graph for the tangent and cotangent. These functions behave differently from sine and cosine because they have asymptotes and unique periodic properties. First, let's look at the definition of the tangent. So we have y is equal to tan of x is equal to sine of x over cos of x. This tells us that tangent is undefined whenever the denominator cos of x is equal to 0. To determine where the vertical asymptote should be, we must identify where cos of x is equal to 0. So cosine is 0 at the following point: negative 3 pi over 2 negative pi over 2, positive pi over 2, and 3 pi over 2. Since tan of x is undefined at this value, we draw a vertical asymptote at this point to mark the boundaries where the function does not exist. So the period of the tangent of x is pi over b. This means the function repeats every 4 pi units. So now let's draw a line between the asymptotes. So we have the So we can repeat the pattern for more cycles. Next, let's analyze the cotangent function. So we have the y is equal to cot of x is equal to cosine of x over sine of x. This tells us that cotangent is undefined wherever the denominator sin of x is 0. To determine the vertical asymptotes, we find where sin of x is equal to 0. So sine is 0 at the following points. So negative pi, negative 2 pi, positive 2 pi, and pi. Since cotangent of x is undefined at this value, we draw vertical asymptote at this point. So we have here. The period of cot of x is pi. Unlike tangent, cotangent decrease from left to right. So we have here, so we can draw a curve decreasing from left to right. We have here. Repeat this pattern for more cycles. Before we wrap up, let's compare the two functions. So the tangent increases from left to right and has asymptotes at negative pi over 2, negative 3 pi over 2, and pi over 2, positive 3 pi over 2. The cotangent decreases from left to right and has asymptote at pi and 2 pi. Both functions have a period of pi, and both functions approach infinity near their asymptotes. So now, we will graph the cosecant and secant function. The cosecant function is defined as a reciprocal of sine, means that y is equal to cosecant of x equals to 1 over sine of x. Since cosecant is a reciprocal of sine, we can use the graph of sine as a reference. So we have here, start from the midline, goes up to the maximum, back to the midline, goes down to the minimum, back to the midline, and continuous process. Since cosecant of x is equal 1 over sin of x, it is undefined whenever sin of x is equal to 0. So we can draw a vertical asymptotes. So since 1 divided by 0 is undefined, so we can put asymptotes. So in 90 degrees, or in pi over 2, we have 1. So 1 divided by 1 is equal to 1. And let's say that here is a half. So 1 divided by a half is equal to 2. This is a 2. So here, and repeat the pattern for continuous process. So here you have 2. So this is the graph for cosecant. Now let's move forward for secant. The second function is the reciprocal of cosine. So we have here the y. We have here y is equal to secant of x is equal to 1 over cosine of x. So we then move to second function. The second function is the reciprocal of cosine. So y is equal to secant of x equal to 1 over cos of x. Now, same as cosecant, for secant we can use the cosine graph. So it is so in cosine graph, start from maximum, goes in the midline, goes on the minimum, back to the midline, and goes out the maximum. Now, same as the cosecant, we can use this as a reference graph. So now we can draw an asymptote, and whenever the cos of x is undefined, so we can put here, that's it. So we can draw an asymptote here and here. Now this is, so 1 divided by 1 is equal to 1. 1 half divided by 1 is equal to 2. So we have here same as here, and a continuous process of a same pattern. Now we know how to graph both the cosecant and secant function. We just repeat the pattern for additional cycle, and that's all. So now let's try to graph a more challenging cosine function. So we have here the y is equal to amplitude of 4 cosine of 3x plus 7. So we have here bend down, raise the midline, back to the maximum, back to the midline, and down again to the minimum, back to a midline, and to the maximum, back again to the midline. So the number of waves is equal to 2. Each wave has a period of 360 degrees divided by 2, so it equals to 180 degrees. Start here, the amplitude. The amplitude is equal to 4. Number of waves is 2. The vertical sheet is 7. So the maximum turning point, so when 4 times 1 plus 7 is equal to 11. And the minimum turning point when 4 times negative 1 plus 7 is equal to 3. So this is the max, the minimum. In the period, we have here a period of 2 pi over 3. So this is the graph for y is equal to 4 cos of 3x plus 7. This is the graph.